guys. Alright, so today we are going to be factoring. We're doing Unit 1, Lesson 3. Make sure you've copied your notes over into your journal and link the slides so that you can click through your slides easily. If you need a refresher on how to do that, if you're on my home page, you can click on the journal and there's a video there telling you how to do that. Alright, so let's get started. So I have made this flow chart. The things we're going to be factoring for today are going to be nice and they're going to follow this flow chart. However, we will have some more special cases that don't fit into this lineup, and we'll have things that maybe we'll get to these and just aren't factorable, okay? So we'll see those cases in a couple days. So the first thing we want to do, our first step is to look and see if we can find a GCF. All right, then we're going to move on. If we can find a GCF, then we're going to factor that out. We'll bring it to the front, and then we'll decide, can we do any more steps? Can we go ahead and do step 2? If we can't, we'll just leave it alone. That'll be our answer. If we can, then we'll see how many terms does the polynomial have. Does it have 2 terms? Is it 4 terms? Or is it 3 terms? So we'll follow these steps and we'll figure out which one do we need to use. All right, so let's look at problem number 1 here. Problem number 1 is 5x plus 25. So is there a GCF that we can factor out? Do y'all remember what GCF means? It means greatest common factor. So what is the biggest number that I can divide out of all the terms? Where's my greatest common factor? Well, in this case, I should be able to take out a 5, right? 5x divided by 5 is just going to leave me with x. 25 divided by 5 is going to leave me with 5. There's nothing else I can do to that, so that will be my answer there. All right, so let's look at number 2. Number 2, we have x squared minus 49. So step 1 tells me, can I factor it? Is there a greatest common factor? Well, no, I have x squared 49. There's nothing there that I can factor out of both pieces. So then I'm going to go on. How many terms does the polynomial have? Well, there's 2. So now A, is it a difference of 2 squares? So does it look like this? Does it look like something that has a squared minus b squared? Or does it look like, or is it a difference of cubes? Does it have a cubed plus b cubed or a cubed minus b cubed? Well, here we have squared, and 49 is a perfect square, right? So I'm going to say that we're going to go with A. So that means my answer is going to be set up as, my answer, my binomials are going to have a plus and a minus. Okay, according to the rule up here, I'm going to have a plus in the first set of binomial, in the first binomial, and a minus in the second binomial. So what it's doing is it's saying that our difference of 2 squares is set up in the form where I have a squared, which is this represented by this x squared here, minus b squared, which is represented by this 49. So if I take the square root of both pieces, then I should be able to figure out what goes into these positions. Because here we're going to have a, here we're going to have b, a, and b, okay? So I have x squared. If I take the square root of that, the square root undoes the square, and I'm left with x. So that means my a value is x. Then I need to figure out my b value, so I'm going to take the square root of 49. Well, the square root of 49 is 7, so I'm going to put that in the place of b. So I now want to, this is our answer, we're finished. Figured out what a and b are, and we've put them in their place. But I want I want to just check our answer really quick, okay? So when we are multiplying binomials, we have to distribute, correct? So we'll have x times x is x squared. X times negative 7 is negative 7x. And then we're gonna, oops, oh my goodness. Wow. And negative 7 times x. Sorry, positive 7 times x is positive 7x. Positive 7 times negative 7 is negative 49. Then we combine our like terms. Well, negative 7 plus 7 is 0, so I'm just going to end up with x squared plus 49, which was my original answer. So we're good. We've checked our work, and it is correct. All right, so now let's look at number 3. Number 3 is x squared minus 5x plus 4. Looking through that, I don't see a greatest common factor. There's nothing in each piece that I can take out. So I'm going to look up here. How many terms does a polynomial have? Well, it's got 3. So what I'm looking for now is, I need to pay attention to the signs. Do I have a plus b plus c, a minus b plus c, a plus b minus c, or a minus b minus c? So looking into my problem, I have a minus b plus c. So I'm looking here in this row. What that means is that my answer should be written in this form. Okay? So I believe in Algebra 1, most of you had Miss Pardo, and she probably taught you the X box method, right, to factor. So you probably remember doing this, and in the top you did A times C, and in the bottom you did B. So here my A value is 1, my C value is 4, so in the top I would have 4, in the bottom I would have a negative 5, and then I'm looking for two numbers to put right here and right here that multiply to give me 4, so they multiply to give me that number, and add up to give me 5. So what two numbers, or negative 5, what two numbers multiply to give me 4 and add up to give me negative 5? I'm going to go with negative 1 and negative 4, right? So up here, I have this little note that says we need to figure out what numbers go inside these binomials here. And the biggest number is going to go into the first binomial. Okay? So my biggest number here is a 4, if I just thought about these as the absolute value of them. So it's 4, so I'm going to put that here and here. Okay, we already have our subtraction signs, right? We already have them negative. So we can still continue using this X method, but eventually I want us to be able to look at this problem and say, I'm looking for, let me pick a different color because I feel like I'm using a lot of black here. I'm looking for a number that multiplies. If A is 1, anytime A is 1, I want to always look and say, I'm looking for two numbers that multiply to give me 4 and add up to give me negative 5, okay? So as we start doing these problems a little bit more, I would expect you just to be able to identify it from here instead of having to use the X, okay? All right, so I'm gonna change to blue, tired of black. Let's look at problem number 4. So problem number 4 is 3x squared minus 6x minus 72. So my first step is there a GCF? Well, anytime I'm working a problem like this, I'm gonna look at my A value. If A is not 1, my first thought is I'm gonna see if I can factor that out so I can make A 1, because it's gonna make my life a little bit easier. So what I want to check is, does 3 go into any of the other terms here? Can I factor all of 3 out? Especially since 3 is prime. The only thing I can take out of it is 3. Well, yes, we can divide 6 by 3. And yes, we can divide negative 72 by 3. So let's go ahead and factor that out. I'm going to put 3, I'm going to put my parentheses. So if I divide 3x squared by 3, I am going to end up with x squared. If I divide negative 6x by 3, I end up with negative 2x. And if I divide negative 72 by 3, I end up with negative 24, right? 24 times 3 is 72, yeah. Okay. Now I need to see, can I factor this trinomial any further, okay? So it's 3 pieces. I'm going to come up here, it's 3 terms. I had 2 negative signs, so I think this is the option I'm going to go with. So that means I need to have x minus times x plus. So I still have this 3. I'll have x minus, x plus, and I need to figure out what goes here. So I can use my x again, right? A times c is negative 24. B is negative 2. So what 2 numbers? Because I'm now looking at this right here, okay? What 2 numbers multiply to give me this number and add up to give me this number? So I'm looking and thinking, my factors of 24, I have 12 and 2, that's not going to give me negative 2. I have 8 and 3, that's not going to give me 2, and I have 6 and 4. So the little note says put the bigger number in the first parentheses. So I'm going to put 6 and 4. Well, that makes sense for the 6 to be in the first parentheses because my b value down here is negative. And if I add up negative 6 and 4, I'm going to get negative 2. All right, so there we go. I'm done with that problem. All right, example 5 is x cubed plus 3x squared plus 9x plus 27. And this is 4 terms. So there's not anything here we can factor out, right? So we are at the 4 terms up here. Let me make this statement really quick. We can factor out a 3 out of each of these terms, correct? But this term doesn't have a coefficient of 3, so we cannot factor a 3 out, okay? I feel like that was a question that maybe somebody would have. All right, so we have 4 terms. Our steps here tell us pair up the first 2 terms and the last 2 terms. So what that's saying is I'm going to group these just like this, okay? So I've put a parentheses in the front, a parentheses behind the second term. I put a parentheses right in front of the first term, the third term, sorry, and right behind the last term. Now we're going to factor the GCFs out of each pair, okay? So what can I factor out of this first binomial? Well, I've got an x squared in common, so I'm going to go ahead and take that out. If I divide x cubed by x squared, we have this rule, a rule that tells us if we are dividing variables, then we end up subtracting their exponents, okay? So if we divide x cubed by x squared, I'm left with 1x plus 3. I'm dividing 3x squared by x squared, I'm just left with 3. So now what can I factor out of this next binomial? I see a 9 in both pieces. 9x divided by 9 is 9. 27 divided by 9 is 3. All right, so my grouping method worked because I ended up with 2 like terms. This looks exactly like that. So since I'm multiplying x squared and 9 by the same thing, I can bring those to the front and show that I'm going to multiply both of those pieces by x plus 3 by making it a binomial. Okay, so the reason I'm able to make it a binomial is because if I were to distribute, I would end up multiplying and getting that piece, and I would distribute the second piece and multiply to get that piece. Okay? So what we're looking for when we're doing grouping is we're going to group, we're going to factor, and what I'm looking for is for those, I'm looking for this piece and this piece to be the same, okay? Once it's the same, then I can rewrite my coefficients on those terms as its own binomial. All right, so let me write down a few problems really quick that you guys can practice on, and you can take a picture and upload them for me. So do these problems for me. Here's 1, 2, 3, and do this one for me. This will give you a little bit of practice. Take a picture and submit those for me. See y'all later.